are still not at the point of actually encoding the words. And you're probably like, Ken, get to the point. All right, let's get to the point. So we're going to write the function now to encode a word. And I'm going to call mine word2num. And so the first thing that I'm going to define is a function, a test for that function. I'm going to go over to the solution real quick. I'm going to grab this test word2num. Not going to look too closely at that function, at that definition there, because I want you to come up with it on your own. Okay, so this is going to be the test. For instance, the letter A. If the word that what I'm coding is encoding is A, that should be 97 because the value of A, the lowercase a in the ASCII table, is 97. If the word is ABC, then it should be the values 97, 98, and 99 added together, which is 294. If there's a bit of punctuation in there, like an apostrophe, it still should be 294 because that should be removed. Here, A, B, C are still the only, actually 4, A, B, and C should all be encoded, but the dash, the apostrophe, and the comma should all be removed, and so that should add to 346. So obviously we're just spot checking. We can't check every single word and value in the universe. This should be enough to at least get started. If in using this program we find that we're missing some other characters, or we find some other edge case that we didn't anticipate, then we expand our test case, and then we fix our code, and then we always run the tests in the future to ensure that we haven't forgotten that edge case that we found. So this is the function. So we want to write the function that satisfies this test. So we can go here. Let me just grab that, copy, paste, and I'm going to call this word2num. It's going to take some sort of a word. Let's see, what's going to be our encode word? How about that? Will be our doc string. And for the moment, we'll just return word. We could say pass. We could return the empty string. For now, we've got something that we know doesn't work. And let's use pytest -xv to run that on our gematria. And what we're going to see is that we are definitely failing word2num, because it's running word2num, passing the letter A, and expecting 97, and what it's getting back is A. And it's trying to assert that A is equal to 97, which is not the case. It wants 97, it got A, so it stopped. So how do we take a word and encode it? So the first thing that we're going to know, that we know we need to do, is, well, we're going to have to bring in, actually, I'm sorry, I'm not going to write this right now. I want you to write it. That's the whole point. So you're going to figure out, taking all the things that we've learned, that we've talked about. So removing the punctuation, applying the ordinal function to each one of the characters, and then summing those values together. That's what you need, your function here needs to do. I'm not gonna write that for right now. I want you to write it. So for instance, if I have this hypothetical function and I pass it the word don't, I should get back the value 405. Notice here that it's returning a string. All of these are strings. Because we're going to need to be printing these, and so I would at some point have to turn them into string values. It was just the way I decided to write this particular function. If you wanted instead to have it test only numeric values, and then you're going to turn that into strings when you go to print them, that's fine. However you want to do that is fine. This is the way I wrote it, so if you're going to use my test, then your function is going to need to return a string. If you want it to return an integer, just change the function and the test likewise, so that they match. So but I will go ahead, so let's think about how we're going to use this function that you're going to write. So the first thing is that we want to preserve the line structures in the text. And so how do we do that? So we have this body of text, and we can call the function called split lines on it. And for instance, if we look here, like if I take the string foo, bar, and baz, and I put new line characters there, and I say split lines, then Python's going to recognize the \n as the idea of a line ending. And so it's going to split that into the 3 separate lines, foo, bar, and baz. And notice here, as is common with split operations, the thing that we split on has been removed. So it's different when you say for line in file and you're reading an open file handle. That new line will still be attached because you're just iterating over the lines as they exist in the text file, and so it's incumbent upon you to remove that new line. But when you have a string like this and you call split lines, then the new line character has been removed. Note too, if you're not familiar with this, is that Windows has a different idea of what a line ending looks like. It's \r\n, and on this \n is typical of Unix platforms like Mac OS and Linux. So generally speaking, Python handles those both. It understands they both are line endings, so it generally handles that just fine. So I'm used to using just \n. I think it's a little bit easier. So if, for instance, our text is "Don't worry, spiders, I keep house casually," then this will allow us to keep those line breaks in place. So it'll be "Don't worry, spiders" will be the first line, and then we can say, for each line in the text, the line will be "Don't worry, spiders," and then we can say for each word in splitting that line, and then we can take that line and split it and put it into words. Actually, I'm looking here, that code's a little bit funny. So the quick brown fox jumps over the lazy dog needs to be split into these particular values, which then need to be put back together into a string that can be printed. So think about that. When we get to the next video, it will be talking about the solution.